All right, problem I'm going to be going over today is max area of island. So you're giving an m by n binary matrix called grid. An island is a group of ones representing land connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water, and the area of an island is the number of cells with the value 1 in the island. Return the maximum area of an island in grid. If there is no islands in the grid, return 0. So what does this mean, right? So we have to check this entire grid for all of the islands, and we need to return the largest island that we find. So I think the best way to go about this is looking at it like your brain does, like, right? So just look at it, right? So we say, we go through and we check every island. So we go through and we check this island, that's size of 1. So then we check the next one, so then we check this island, and that's the size of 4. So then we go, and then we skip this, and then we go, and then we go here, and then we check this, and then our size is 4. Check this, size is 5. Go through, size is 6, so now our max value is 6. So we go through, skip all these values, go through again, until we get to this one. And then we get this size is 5, our max is still 6. So then we go through the rest, and then we return the max value of 6, because that's the largest value we find. And honestly, there's not much more to it. That exact approach right there is exactly what we're going to be doing. We're going to be iterating over every single value in the entire grid. And when we come upon an island that we've yet to visit, then we check that island for its size. How do we do that? We do that with a depth-first search. We can use a breadth-first search or a depth-first search. I'm going to be using a depth-first search because I think it's easier to implement. I think it's maybe a little bit slower just because you're using a recursive call stack, which is extra stuff that doesn't really matter when we're talking about an interview problem and we're looking for just basic asymptotic analysis. So if we're going through and we check this one, we go to this island, well then we're going to check depth first every single adjacent value. And if that adjacent value is a 1 and we've yet to visit it, then we continue our search, right? So let's check the left, it's not a 1, not a 1, not a 1, and out of bounds. So then we continue. That's our size of our island is 1, and that's the max that we found. 1 is our max. So then we go through the rest, and then we get to this one, and then we check all the values to the left, and that's nothing because it's a 0. We check all the values above, nothing, it's a 0. Check all the values to the right, nothing, it's a 0. And then we check all the values here, and then we just pick a direction. Let's say we go down, right? So we're just going to continue going down. So then we go here, and then we go here, and then we check here, and then that's a 0. And we don't continue checking that way. So now let's check all the values to the left, right? We check all the values to the left, and that's 0. So we're done checking all the values to the left because this value, we know that this isn't correct. So now let's go and check all the values above this value. Well, this is, we already visited this one, so we can mark it off with an X. So now we check all the values to the right. So we check this value, 1. That is fine. So now let's check from 1. We continue going in that direction. So now let's check this one, and then we check this one. That's a 0. So now we go back and we check this value. We check all the values below it. That's a 0. We check all the values above it. 0. So now we go back. We mark this as visited. We go back, and then we check all the values below it. That's a 0. Check all the values above it. Visited. Then we go back. Do the same thing. And then we've checked all the values, and we know that the size is 4. So now we know the max value is 4. So then we go through all the rest. We do that same process for this guy. So let's check all the values below it, and then cross off, cross off, cross off, 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 and then we check all the values over here, cross that off, and then check this one, and then we've checked all of that island. Continue going, do the same thing here, 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 and then we're done. And we do the same thing until we get to this guy. That's value is 6. So 6 is now our max. the same thing for the entire array, and then once we finish, we return our max. And that's our answer. All right, so how do we actually program this? How do we write this up? So we would, first of all, we would go and we would define a 2D array called visited. So this is going to keep track of all of the islands that we visited. So we'll say visited is equal to, there's a Pythonic way to do this, is what they say, right? So you have, you define a 2D array, the inside being the size of the columns, and then we say for I in range rows. And then let's define, forgot to define rows and columns, so up here we'd say rows, cols equal to grid, length of grid, then length of grid 0. So, whoops, not gird, grid. So our columns are going to be equal to rows, or sorry, not our columns are going to be equal to rows. The length of the grid, so the size of our M, is going to be equal to rows, and N is going to be equal to columns. So now we're going to keep track of the largest island that we find. So the largest island that we know is going to be in the list is going to be 0, right? Can't have a negative island. So we know that our minimum value is going to be 0. So then we go and we check every single item. We need to check every single portion, right? So for M in range rows, for N in range cols, if that value is an island and we haven't visited it, so if grid M N, keep saying gird, if grid MN equals 1 and visited MN is false, so and not so sorry, if it's true, if it's false, if we haven't visited it, then we say that the island size is equal to our depth first search starting at position MN, and then we just say that largest island is equal to the max of our current largest island and this island that we're now checking. And then we can go ahead and return the largest island that we find. So if we assume that we had already written up our DFS function somewhere else, then that would be it, and that would be the end of the problem. This would give us a correct solution, but we haven't. So we have to go and actually define the DFS, which is going to be the tough part, but it's the scary part. But once you really start looking at it and you start breaking it down, you realize that it's not really the tough part. It's not very difficult, right? So if we know that we're already checking all the values and we know we're keeping track of if we visited the value or not, and we know that our loop is just going to check all those values, then we just have to check for the size, right? So we'll say define our DFS, taking parameters M and N, and then now we know we're going to write this recursively, so we need to define a base case, right? So if this is the case in which we're going to return false, or this is the case in which our recursion is going to break. So when is it going to break? When are we going to stop searching? Well, we're going to stop searching if we come across water, right? Or if our value that we're checking is out of range, right? So if our size is 5 by 5 and we check the 8th by 9th position, we know that that's out of range and we shouldn't check there. And also if we visit an island that we've already visited, we know we should return because we know that there's nothing else down that path. So let's go ahead and write that up. So if M is less than 0, or M is greater than or equal to rows, or n is less than 0 or n is greater than or equal to columns, right, because we're 0 indexed, or visited n, right, if we visited that island, or if, what was the last part? Or if grid, keep saying grid, if grid n is equal to 0, right? If it's equal to a water item. Or if it makes more sense to you, we can just say it's not equal to land. This is probably the better way to write it, because let's say there were like extra constraints, like we shouldn't count, I don't know, 3s because 3s are bombs or something. I don't know. Problems can get weird, so it's better to check for like the specific test case that you're looking for, right? So if it's not an island, we should continue. We should be pretty explicit about that. So if any of these are right, then we should return 0 because that's the end and we don't want to keep adding. Other than that, we can now define a count, and this count is going to be equal to the size of our island. And this is where we really define the meat of our depth first search, right? This is the recursive calls. So we need to check recursively up, down, left, and right. How do we do that? It's kind of exactly how you think, right? So we need to define a DFS for up, down, left, and right. So we do DFS of m plus 1, n, and then we're going to add that to the DFS of m minus 1, n, and then we're going to add that to same thing again. We can actually just copy paste this guy. And then edit these values, right? So m and n. So our count is going to be equal to the depth for search down, left, right, and up. And then we can just go ahead and return our count plus 1 plus count, because we need to return, for every value that we check that is a correct value, we need to add 1 to it. And we add 0 if it's not correct. That's our base case. And lastly, we need to go ahead and define, once we know that we're visiting the correct one, we want to mark that before we continue a depth first search on a different node. So we say visited m n is now equal to true. And now I believe we can go ahead and submit, and we will have the correct answer. Yeah, so other than a couple of tweaks, right, I had a few mistakes, right? This should have been in, I had that out, and we need to explicitly define this as false, and then it should return true. So we run it, and it's pretty efficient, 67%. Couple notes, time complexity is going to be m times n, because it's going to be equal to the size of the array. Same thing goes for the space complexity, because we're defining this visited. And if you're in an interview and they ask you to write it in O of 1 space, the way you would do that is by not checking visited. You can actually just flip the 1s to 0. So if we go to this description, you can, once you visit this item, you can go ahead and just flip it to a 0 and then check the next one. And then when you go ahead and check it, it'll just say 0. So you know you shouldn't check that again. The only problem with this is some problems won't let you change the value of the array. You're not allowed to explicitly change any values. So I think it's just best practice to define a visited array. But if they ever ask you to do it in O of 1 memory, or O of 1 space, then that's how you would do that.